All right, welcome to 52 weeks of AWS. I'm going to go ahead and get started here with continuing on the discussions around the AWS machine learning certification exam and how to prepare for it. This is week 2, so I'm going to get into the details about what is machine learning. Really, that's the key topic. So let's go ahead and get started here. I'm going to go ahead and share my screen. And let's go ahead and get this going. So to go ahead and get started on this material, I'm going to just open this thing up for a second. There we go. So at the end of this module that we're going to talk about, you're going to be able to recognize how ML and deep learning are part of artificial intelligence. Also, we'll talk a little bit about artificial intelligence and machine learning terminology. We'll identify ML, how it can be used to solve a business problem, talk about machine learning processes, also list the tools that are available to data scientists and identify when to use machine learning instead of traditional software development methods. First up, let's get into the concept of machine learning. What is it? At the highest level here, we have artificial intelligence, and that's where we're able to really get into the details here, or into the weeds a bit, and talk about high level, let's say robots or an autonomous vehicle, etc. It's the whole package of things together. That's artificial intelligence. When you get into machine learning itself, you're really more diving into the weeds of a prediction or classification of some kind, or discovering labels for data, like in the case of clustering. And then deep learning refers to using neural networks. So it's a particular type of machine learning, and it's used with large data sets, and it also uses deep learning. A very popular deep learning library is TensorFlow. So what about artificial intelligence here? If we dive into the details a little bit more. So this is a broader field inside of computer science, and it's about building machines that can perform tasks that a human would normally perform. So really a form of automation that's intelligent. That's really a good way to think about it. But some of the things that people do with AI is natural language processing, reasoning, knowledge representation, physical environment interaction, and also there's some ethical considerations as well with AI. So if you get into machine learning, though, this is getting more into the scientific study of algorithms and statistical models, where you perform a task by doing a inference, right, a prediction. And you need data, you have a model, and then you go through and you create a prediction. And in particular, one of the things that is important about machine learning is that it must, it requires data in order to be able to do something. Now, if we get into deep learning, this is a technique that's associated with machine learning. Really, it's living inside of this, and it is based on how a human brain works, and an artificial neural network, or an ANN, is inspired from a biological neurons in the brain. And in particular, neural networks are composed of layers of neurons with connections between the layers, and the output of a single neuron connects to the inputs of the neurons in the next layer. And throughout this course, we're going to talk about how to optimize models, and also some of the techniques that go with deep learning. And so really, deep learning has actually been around for decades. I remember first hearing about neural networks in the 1990s, actually, from a professor at Caltech who was involved in some of the research. And so they've been around quite a while, but the techniques actually haven't been able to be used until recently, due to advances in hardware and also the storage capabilities. So if we talk about ML and technology advances with traditional computing, you would have, let's say in the mid 2000s, you had the physical data center, and this is the start of some of the underlying technology that was necessary. but because of Moore's law and the rise of cloud computing, you're able to get larger and larger data sets, larger capabilities. But now with some of the things that are occurring with cloud computing, you're able to actually use these resources on an event-driven architecture. So you're able to much more basically use resources in a way that's efficient, and also use resources that would be very difficult to use, like a extremely powerful deep learning system, hardware, quickly solve a problem and then spin it back down. So a few takeaways are that AI is just a machine performing human tasks. ML is training models to make predictions or to also discover labels. In the case of clustering, deep learning is neural networks. And cloud computing in particular has actually been a huge driver. You could even make the argument that if you don't have cloud computing, you can't do deep learning. Okay, let's talk about some of the business problems that are solvable with ML. A very good example would be spam, right? So you're able to classify spam versus regular mail. So this would be a classification problem. Every time a message comes in, you have a model that's trained and knows whether something is spammy. Like, spammy would be like, hey, give me money. I have a great investment for you. Once the model has seen enough of this, it knows to classify it as spam. Recommendation systems, something I've built before, real companies, is a good example. So you look at previous purchases and you're able to recommend new purchases. Fraud would be a great one as well. So how would you classify this? You would basically have a data set where there were fraudulent transactions. So for example, if the person that's making transactions, the last transactions that were made were in one city, but then now the credit card it appears in a new city, but then there's still charges being made from the previous city. That doesn't sound like a good scenario. That could be a typical fraud scenario. So the model is able to be intelligent enough and classify that as a fraud, or it needs to be suspended. So these are really good examples of common ML problems. So what about the types of machine learning problems? The first one to be aware of is supervised machine learning. And this is where a model, you know the labels of the data. So you're able to have historical data, let's say points scored in a basketball game, and you're able to actually use that to train a model. There's also unsupervised machine learning where you really don't know yet what the labels are on the data. So let's say there's pictures of images in a warehouse. Maybe you don't even know what those images are yet, right? So you'd first, have to do something to discover some labels, and that's where clustering can come in, is able to discover the hidden labels. And then reinforcement learning is where a model is going to interact with its environment and learn from the actions, like a pet or a child. It would be a good example of how reinforcement learning works. On the AWS platform with reinforcement learning, they have Deep Racer, which has got a very good example of how to do reinforcement learning by interacting with their simulation. Okay, let's talk about supervised learning. In particular, this is a popular type of machine learning because it's widely applicable, and it's called supervised because you need to have the labels, right? So you need to know the right data. Some things that you can do with supervised machine learning would be classification. And so in case of classification, binary would be a simple type of classification. Is an email spam or is it a valid email, right? That's a good example of a binary classification. For a multi-class classification, this would be potentially if you had multiple kinds of animals, like if you trained a computer vision model to predict between a cat, a dog, a dolphin, etc. That would be a multi-class classification because there's multiple labels, and each of those labels your model is able to predict. In the case of regression, what a regression is it's a numerical value. So, for example, stock price, you would be able to predict what that stock price is, and so you'll see a lot of regression models in maybe the finance industry. Okay, computer vision is a very large field, and in particular, you'll see a lot of classification things come up with computer vision. Is it cat or dog? Is there a tumor? Those kinds of things. And computer vision enables the machines to identify people, places, and things with accuracy, either at the same level as a human or potentially better. And in some cases, the computer vision can even do things like detect patterns that a human could never be able to detect, because there's something unique about the data that it's been able to see. So there's some ways to even use computer vision to enhance the regular abilities of human. Now, in terms of unsupervised machine learning, the idea is you want to really discover new things, and in particular, with clustering, when you would use this would be product recommendations or customer segmentation. So a good example would be if you're able to identify, let's say, the kinds of customers that bought. Let's say you had a data set that had the purchase price, the frequency of purchasing that particular item, and then maybe the total sales per quarter by that customer. And you're able to take those three columns, and you're able to create some kind of clustering algorithm. It may be able to discover that there's three kinds of clusters of customers in your company. One of them is, we'll call them the whales, right? The really rich people that are buying, lots of things. And then maybe there's a normal customer, and then there's some customers that just don't buy anything, or they buy very, very infrequently. In terms of dimensionality reduction, this is used in visualization. So if you have, too many different things to visualize, too many features, you would shrink it to the principal components, and so you would be able to deal with the problem. You also see dimensionality reduction used in conjunction with clustering, because the clustering algorithms have an issue with the curse of dimensionality, which means that basically you have so many different data points to look at that everything is next to everything. And so what you do is you reduce the signals so that there's only a few signals, the principal components, and then cluster on top of that. Now, natural language processing is actually very widely used now. It's becoming more and more popular, and you're seeing lots of examples of NLP happening. And in particular, one of the things that we're seeing is in chatbots, translation tools, voice to text translations, sentiment analysis, summarization. Lots of these kinds of things are available. And in fact, they're even available from Amazon Web Services. Now, if we go into reinforcement learning, as I mentioned before, the pet or the child is a really good example of it. That reinforcement learning is learning through trial and error. So you would have self-driving cars, robotics, customer service routing. And so in particular, the system on AWS where you can play around with this is AWS Deep Racer. And the idea is that you give actions that are reinforcements to the Deep Racer, and it's able to actually use that to train a model. And there's a few different key words here. So the agent, that's what drives the learning. And in the case of Deep Racer, the agent is a car. The environment is the place where the agent learns. And so this would be a racetrack. And then there's also a response, and this would be an action. So the response is a reward or penalty, right? So if it went off the track, you would potentially give it a penalty, but if it stayed on the track, you would give it a reward. Now, a very good example of using machine learning would be self-driving vehicles. And so this puts a lot of different disciplines together. So it could be potentially computer vision problems, reinforcement learning problems, regular supervised machine learning, unsupervised machine learning, but it's the combination of all these together that makes it a multidisciplinary machine learning problem. So when do you want to use machine learning? So the classic use case for machine learning would be you have large data sets and a large number of variables. You don't have clear procedures on how to obtain the solution. You know people that potentially have machine learning expertise, and you also have an infrastructure that's in place to support it, right? So you have maybe a cloud computing environment, and then maybe the business leaders in your organization have support for it. These are all use cases for using machine learning to solve a problem. Okay, let's talk a little bit about a machine learning pipeline or a business problem. At the very beginning, when you're starting to build a machine learning pipeline, you should start with a business problem. And so this would be under the problem formulation. So this is a place where you could get things wrong even before you start, because if you're solving the wrong problem, then even if you did a great job at solving the problem, the organization you're in won't be able to use it. But once you have formulated that, the next thing would be to collect and label the data. And this can really be time consuming. And one of the most difficult parts of a real world computer vision problem or any kind of a machine learning problem is that, is your data actually clean? Were you able to collect it and store it somewhere and then label it, potentially even using something like a feature store, which is a kind of an emerging standard here. And then finally, you would need to go in here and actually look into the data handling and cleaning. For example, if the data says 11/2/1969, it could be also November 2nd, or it could be February 11th, right? You have these weird edge cases, or there's somebody, for example, like Anthony Davis. You see a name. There's an Anthony Davis that is a NFL football player, and there's an Anthony Davis that is a NBA player. Which one do you mean, right? So these kinds of problems can really have a huge impact, and they seem subtle until you actually try to train the model and then things don't work. So with machine learning pipelines, it's an iterative model training approach. So you start with the problem formation, collect the data, evaluate it. Now, once you get into the machine learning process, you have to develop features and look at what are the things that are giving the signal to the model, select and train the right model. So are you using the right algorithms, maybe even using an AutoML system that can help you with this, and even pick the right hyperparameters. Once you've evaluated it, you then see if deploy it and say, does it meet your business goal? If it does, then maybe you're good. If not, you may have to go back and tune the problem. But also, it's possible you want to constantly be reevaluating your model once it's in production. This is kind of the MLOps style. So an ML pipeline would include feature engineering, and in particular, a few things to look at would be, basically you could select or create new features that you would use to train the model. And it could be like a data cleanup on a name column. So you could maybe make the format consistent for later on. It could even be just cosmetic, right? Like if you don't like the way the column is named, you change it to something else. You could also convert maybe a country into a numeric or binary set of columns. And that could be a good way to solve a problem. So let's say the UK would get turned into 44, or USA would turn into 101 or 01. And part of the issue here is that it's important to realize that machine learning, the way it works is it has to be done on numerical data, right? So all machine learning is, for the most part, using data that's normalized or scaled, let's say between 0 and 1, and also that it's converted to a numerical format. So in the case of, let's say, sex, right? If it was male or female, you would have to convert that to a 0 and 1. If it's a date of birth, potentially you would have to, maybe shift that into a month or a year or something like that. And then once you go in and you train the model, then you would need to pick the right algorithm. Potentially, again, AutoML could be a huge help here, but let's say your algorithm is XGBoost. You would go through, pick the hyperparameters that would make the model get the best result, and then go ahead and train that model. And often you will hold back, let's say 10 to 20% of the data, so that you can now test the data to make sure that the thing you trained on actually corresponds or basically is able to work on data that it didn't see itself during the training process. If you use all the data, then you could get something called overfitting, which means that you're basically not generalizing enough. So when you're tuning your model here, the test data is a huge important part of it, because it shows you how the model performs, and you can take an instance that the model hasn't seen. For example, let's say in the case of pictures, like if you're training cats and dogs, you'd save a bunch of pictures of cats and dogs that it hadn't seen to make sure that it was able to perform correctly. And then you would calculate how well it was able to do the predictions on the data it hasn't seen. And this is a metric that you would use for evaluation. There's also the concept of overfitting and underfitting. I got into that a little bit, but basically, when you train your model, you have to understand overfitting, underfitting, and a balanced representation. So if your model is overfitting, it means that your training data is able to perform well, but it doesn't perform well on the evaluation data. So basically, your model is memorizing the data it saw, but it can't generalize to new or unseen examples. And this is a classic case of overfitting. So, basically, going too closely is some strange pattern. In the case of underfitting, this is when your model is underfitting the training data to poorly capture the training data, so that basically it doesn't fully capture the relationship. A great example of this would be, let's say you have a exponential data set. There's an exponential relationship between y and x, and so there would be like a super linear line, but you've made the underfitting problem of making a straight line. So for some of the data it'll work okay, but when you get into the exponential components, let's say you're building a system that was able to pay money to celebrities. Well, there are some celebrities that are so popular that they're exponentially more popular than other celebrities. It wouldn't be able to generalize well enough to that example. But in the case of a good fit, it would be that you're finding the root case for poor model accuracy, and you're able to kind of solve this and fix it out so that you get a balanced approach. So let's talk about deployment. After you've retrained a model and you're satisfied with the results, then the next step would be to potentially retrain this and deploy it. A lot of times, though, the Amazon machine learning services will do all the work for you. All right, let's talk about machine learning tools overview. In terms of Python, there are really a small set of tools that you'll see all over the place. We've got Jupyter Notebook, we've got Jupyter Lab. These would be notebook-based solutions. We have Pandas, which is a library that's used to deal with data that's in a data frame or kind of a columnar style. Matplotlib is a classic plotting library. We have Seaborn, which builds on top of Matplotlib. We have NumPy, which is a low-level scientific computing library that uses NumPy, that works along with Pandas, and then scikit-learn for machine learning. So Jupyter Notebook is an open source web app that enables you to create and share documents that have equations, visualizations, narrative text. The use cases include data cleaning, transformation, numerical simulation, statistical modeling, data visualization, machine learning. Jupyter Lab is a web-based interactive environment for Jupyter Notebooks, code, and data. And the lab is a little bit more flexible, and you can use it with multiple users. And SageMaker itself actually uses both Jupyter Notebooks and Jupyter Lab. Pandas is an open source library. It's used for data handling and analysis. It represents data in a table, right? So it's a lot like a spreadsheet. And Matplotlib, as I mentioned before, is used for scientific, static, animated visualizations. Seaborn's built on top of that. NumPy is good for working with functions for in-dimensional array objects and math. And scikit-learn is the open source ML library. So machine learning frameworks and infrastructure. Machine learning frameworks are used for customized scripting, integration with AWS services. There's a community of people. Examples include TensorFlow, Keras, Apache MXNet. And so the Amazon instances that are designed for machine learning, these include AWS IoT Greengrass Amazon Elastic Inference is a good example as well of something that would reduce costs for running machine learning. And what's nice about these specialized instances is they will have all these libraries installed for you. The Elastic Inference is pretty interesting because it could efficiently do predictions because it would use just enough of the GPU. So you wouldn't have to use the whole GPU. And now that we're getting into the capabilities on AWS, we have to talk about SageMaker. And in particular, SageMaker can deploy machine learning instances that run Jupyter notebooks in lab, and it manages the deployment of the compute resources. It includes tools for labeling data, training models, hosting trained models, and the marketplace provides a selection of ready-to-use model packages and algorithms. And so some of the things that SageMaker can do would be ground truth, and this would be labeling data, notebook. This would be for handling the really building out models. Training would be training the model. Inference would be predicting. And then the marketplace is finding ready-to-use products like model packages, algorithms, and data products. So in particular, I think a good place to kind of dive into would be to play around a little bit with SageMaker. There's also something called SageMaker Studio Lab. If you're a student, you can just Google that. If you want to try SageMaker, though, you can also go into the free tier and play around with SageMaker on the free tier. So talking a little bit about machine learning managed services on AWS, a few of them to talk about in terms of managed services. And I guess first I should say, what is a managed service? It means that you don't have to deal with the underlying infrastructure, so like virtual machines and networking and those kinds of things. And so in terms of managed services, there's computer vision would be recognition, and this can do object and facial recognition for image and video. And Amazon Text Extract can extract text from images. We've got speech, so Amazon Poly can do speech to text. Amazon Transcribe can convert spoken audio to text. Amazon Comprehend can find insights like entities, for example, in a document. Amazon Lex does chatbots. Forecasting is using ML to do time series data. Recommendations, Amazon Personalize would be doing recommendations. So there's lots of examples of these high-level services. Okay, let's talk about typical problems that occur in the real world with machine learning. First up, in terms of data, one of the things would be a large amount of poor quality and inconsistent data. This is a classic problem. And how do you actually get good data? And does the data represent the problem well? So if you're trying to find credit card fraud, really there could be very few examples of fraud. And so you have an imbalanced data set. And in many cases, the more data you have, the better you'll do. And then also, are you underfitting? Are you overfitting? Or do you have a balanced representation? And it's important to know which one. Now, in terms of users, one of the things to be aware of is, do you have data science experience on your team? Are you using staffing of data scientists in a cost-effective way? And does your management actually support machine learning? Business, for example, are the problems too complex to put into ML? What is actually the cost of building these models and operating them? Maybe even a good question would be, what's the ROI? Like, is it actually making sense? And then in terms of technology, like, what are the data privacy issues, and also what is the framework that you're using? Now, in terms of ML, some of the existing models and services that if you don't have any ML experience, you can use the managed services. You also can use you only look once, which is using trained or tuned models. We see this a lot with Hugging Face as well. So I think this is an emerging category, is just using models that someone else has built. So there's a lot of different ways that you can actually use machine learning on the AWS platform. All right, so that's pretty much everything that I wanted to cover today. And so maybe wrap up with that. I think the big takeaway here is that if you have a chance and you want to get into machine learning on AWS, you got to use SageMaker. Just kick the tires. There's lots of great features in terms of SageMaker, and they work on the free tier of SageMaker. All right, that's it for today. Next week, I'm going to get into more details on the certification exam. I'll dive into building pipelines with SageMaker, so I'll get a lot deeper into SageMaker next week. All right, see you then.